13th one is 9, and the 0th one is 10. Now, you know, computer scientists are quite happy using 0, say the 0th one. Let's say the one you start with. So I tend to start with 1, but then sometimes when 2 or 3 weeks later, I'll just start with 0. Please be aware of that. So you have a set that is indexed. So you will need a set notation. So these are not set, these are not sequences. Not sequences. Because they're just sets. So you will have a set of numbers, but then you will have to say, oh, this number comes before that number, that one comes after that. This is your index, and this is your element. Now this has got, there's no telling what this is. It could be fractions, it could be negative numbers, it could be complex numbers, it could be whatever you want. It's just that you have a set, and it is ordered. This is the first one. This is the second one. This is the third one. Now, if you understand this, you can kind of start creating some sequences. Now, computer scientists make sequences in a very strange way. Anybody know how computer scientists make sequences?
Like an array or
Because they're talking to machines, and how do machines understand what sequence is? They say, well, take the number 5, that will be your first one, and then to that add 2. That will be your second one, 7. And then to that one add 2. That will be your third one, 9. They call it
loops.
recursion. You see, you define it recursively. You say, if you want to get the 10th one, if you want to get the 10th one, take the 9th one and add 2. Well, now, what's the 9th one? Well, take the 8th one and add 2. Oh, well, take the 7th one and keep going all the way till you get the first one. The first one they have to tell you. They'll tell you the first number is what? 7, and the common difference is 2. Of course, if you talk to a pre-calculus student, they say, hey, I have a sequence in your mind. You say, hey, what's the sequence? It's an arithmetic sequence. The first term is 7, and the common ratio is 2. Oh, good, we'll know what you're talking about. All right? What is it? It's an arithmetic sequence. The first term is 7, and the common difference is 2. So, well, the next one is 9, yes. The one after that is 11, yes. The one after that is 30, yes. Good. We both know what sequence you're talking about. So, computer scientists will say, oh, okay, the first term is 7, and the common difference is 2, so you just keep adding 2s and build up the sequence. So that is, they also teach you that on pre-calculus. Right? That is to say, the 10th one is the 9th one to which you add 2. And the 11th one is the 10th one to which you add 2. And the 15th one is the 14th one to which you add 2. That is one way to do it, and I'm not going to do it that way. I may sometimes do it that way. I think they can't ask.
They do it in the discrete math.
Of course they do it, because they were teaching computer science. Yes. Let's just do it the mathematical way. Anybody know what is a good way to create sequences without doing recursion?
Sigma notation.
Huh?
Sigma notation.
Do not. Oh, thank you, Mr. Matthew, for jumping into the fire. Do not confuse these two things. When you use the sigma notation, you are done with your sequences you were talking about. Series. I don't know what a series is yet. Let's just get our hands around the sequence. Okay? Then we'll start to crawl and then we'll start to walk. Now, anybody know what an easy way?
Compare it to a function.
Oh, you're on the right track. Evaluate a function at the integers. Look at the first one, the function at 1. Evaluate the function at 2, you look at the second one. Let me show you. Give me a nice function.
X
Huh?
squared.
This is hard. Let's start with something easy. How about 1 over x? F of x equals 1 over x. We want to graph the function, right? It looks like this, right? F of x equals 1 over x. Now you take this function and you evaluate it at the integers. Give me an integer. Don't evaluate it at 0, okay? Even the computer scientists can't do that.
Okay, 1.
How about 1, yes? What is it?
1.
And a 2?
1.
And a 3?
1/3.
1/3. And a 4?
4.
That's my sequence. You take any other function and you evaluate it at the integers, you're going to pick up a sequence. Right? Yes. So here, my AI would be 1 over I. That is to say, if you want to know the first one, it would be 1 over 1. And if you want to know the third one, it will be 1 over 3. That is to say, take 1 over x and evaluate that. Here's my sequence. Okay, let's try it with another function. Who can give me a little more complicated a function than that? Oh, give me a line, any line you like, Mr. Rodell.
2x plus 1.
2x plus 3? And we will evaluate this at the integers. What's this?
It's 3.
5,
7.
9. What sequence is that? Arithmetic sequence, the first term is 3 and the common difference is 2. So every arithmetic sequence is coming from a line. Common difference is the slope. Think about it. Yes. So that will be nice. I'll change the letters to B, is that okay? Sure. And I'll change the index to K, is that okay? 2K plus 1. What is B1?
3.
3. What is B2?
5.
What is B3?
7.
So you can do this any old function. That's how you pick up sequences. You just take that function and you evaluate it at the integers. Mr. Matthew, another nice function you would have learned in pre-calculus.
Squared.
X squared over, actually that one you learned in college. 3 to the power x. You learned that one in pre-calculus, Mr. Britta? You don't remember exponential functions?
I remember.
Oh, good.
Okay, so.
Okay, so we're going to evaluate this at. Well, this one you can evaluate at 0. What is this?
1. 3. 9. 3.
Huh? It's your sequence. Let's call it C. CM. What's CM? 3 to the power M. So C1 is 3. C2 is 3 squared, 9. C3 is 27. C4 is C with 4. C1. What sequence is this?
3 to the.
This divided by this.
It's 3.
This divided by this.
9. Or 3.
This divided by this.
3.
What sequence is that? Geometric sequence, common ratio 3. So, the long and the short of it is that Arithmetic sequences are really lines at which you are evaluating integers. Geometric sequences are really exponential functions at which you are evaluating integers. So if it was 4 to the power x, my common ratio would be 4. If it was 2/3 to the power x, my common ratio would be 2/3. I will see you on Tuesday.